This task uses a standard deck of playing cards with no jokers in it, and it asks us to write a function which enables you to transform the card's value from being the face value on the card into being a numeric value. So we're going to have to write this as a separate function. So under the main method, I'm going to clear some space and set up my function. I'm going to set it as private static. Don't worry about the meaning of those words. And this thing is going to return an integer. So functions obviously have to have a returned value, and they always return a single value, and in this case it will be an integer. I'm going to call the function getValue, and I'm going to feed into it then a playing card, but I have to give some thought as to what the data type is going to be of this playing card variable that I pass in. So we do have the char or car data type available in Java, but the number 10 presents us with a bit of awkwardness because we can't pass in 10 as a single character in such a way that it can be used elsewhere in the program conveniently. So I think we'll scrap the idea of using the character data type. We'll probably stick to strings here. There are other possible ways to do it in Java. There's enumerations, for instance, but we'll just stick with strings for convenience here. And so I'll label the data type of the parameter as string. Next, we will think about where could we start. I'm going to suggest that we start with the letter values in playing cards, the ace, the jack, the queen, and the king. So let's begin by saying that we could, in this case, use some sort of maybe a switch statement in order to achieve selection. So what we could do here is we could switch on the basis of the card, and we could say that in the case that the card that we get is the ace card, that it would very simply return the value 1, and we wouldn't need a break statement there because we're returning. In the case that we get the string j, then we would return the value 11. In the case that we get the queen, then we would return the value 12. And the final letter value then would be k for king, in which case we would return the value 13. In the default case, we probably just shouldn't return anything, and we should then look at maybe using this as the place to deal with the numbers. So switch statements by design should really have default cases to mop up all the other eventualities. So what we're left with then are the numbers from 2 to 10 trapped inside a string. So let's assume that the value that is passed in as a parameter can only be a valid card. And let's not think too much about how things can go wrong in programs. So let's bomb on ahead with trying to solve this, where we come up with maybe sort of an if statement or some other strategy for working out the value. If you take a string that we know contains a number and you walk through the string and you extract the number value from it, we call that process parsing. And so there's a built-in class called integer in the Java language, and we can use the parseInt function that it provides. And what we can do there is we can parse the string called card, and so we will have the number value of that card. This variable only needs to be brought into existence in the eventuality that the card isn't one of the 4 letter characters. Having now extracted the number value out of the card, that means then that we will be able to return that value. So actually, rather than storing it in a variable which we then return on the next line, what we can do instead is we can simply combine these 2 lines and say that having extracted the value from the card, we can now return the numeric value from the card. Now, that gives us a working solution, we hope, to the problem, but doesn't take account of maybe the need for validation or some thought about robustness. One general concern that we can address quite easily here is that the value passed in as the card may not be provided in uppercase, and so that's something that we can do a quick tidy up of. We can say that whatever case the letter is passed in, we can always say that the card will always be converted to uppercase. We can use the IDE to help us here, just to pick out the correct formation of to uppercase in the naming of the function. Alright, so what this does is it adds a little bit more in the way of robustness to the program by getting us to think about sanitizing the input that was provided to the function, the input parameter. Sanitize the input to turn it uppercase. I'll say the parameter provided. Alright. So before we go any further and we start considering robustness, let's test what we've written with some valid values and look for any unexpected outcomes. So we have system.out.println, and we are going to now call the function getValue. Let's just take a copy of it, Control C, and get it set up. And so we will provide a string for a card. Let's begin with, for example, a jack. Let's take a copy of this. Maybe try 4 different eventualities. Let's try the jack, let's try the ace, let's try the number 6, and let's try the double digit number 10 as well. Okay, so 4 valid values. Let's save this and let's go ahead and run it. See what happens. So we have an 11 for the jack, we have a 1 for the ace, we have a 6 and a 10, which looks good, looks healthy. Okay, so this is a solution to the problem, and now we can turn our attention to thinking about improving the robustness. So let's say, for instance, that the card that is passed in is an empty string, or perhaps even a null value. That's probably the first thing that we should deal with. Okay, so eliminate null values and empty strings. This gives us an opportunity to talk about an interesting process known as short circuit evaluation. This is where Java tries to take a little bit of a shortcut when it's performing the evaluation of a Boolean expression. So let's build an if statement inside the round brackets of which we're about to put a Boolean expression. So we'll begin with if the card value is equal to null, and then we'll say, well, the other thing that it could be is potentially an empty string. So we'll say if it's null, or if the card value dot equals, and this is where we check to see if it's equal to the empty string. So in the Java language, if you want to check if a value is a null value, basically if it's not one of the 8 primitive data types, then you can check if it's a null value. That doesn't apply to the 8 primitive data types. And similarly, because this is a string, we use dot equals to compare the equality of 2 strings rather than using the double equals sign. And so what's going to happen here is if you do pass in a null value, then card double equals null evaluates to true, and because the left hand side evaluates to true and it's coming before an OR symbol, the true OR pattern always evaluates to true regardless of what's found on the right hand side of the OR symbol. And because it always evaluates to true, Java just says, well, if I know that it's a true and that it's an OR, then I don't need to even look at the value on the right hand side. I know what the outcome is going to be. And we call this short circuit evaluation. So in this case, if the card is indeed equal to null, Java will not proceed with judging whether it's equal to the empty string or not. It will simply move on and say that this entire Boolean expression has evaluated to true already. In this case, let's write an error message to say that no string given, and then let's return a value because all function pathways have to return a value, and we'll use -1 as a kind of a dummy value and just return that. We can now add a couple of test cases to our program so that as we're testing this we can make sure that it works. So we'll initially try just not passing in any string at all, pass in a null value, and secondly we'll pass in the empty string. Next we go back and we say that we know for sure once we get to this point in the program that there is something within the string. The concern now is, what if it's something that's not a valid playing card? So we begin by converting any letters to uppercase. That's acceptable that we would do that at this point. And then we can start using our switch statement. So the switch statement is saying if it's a capital A, a capital J, a Q or a K, all in capitals, then it will deal with it accordingly. By default then, it's going to instantly jump into assuming that it's got numbers in it, those numbers are within a valid range, and it's just going to pass back the value. So this is obviously the area of concern here. So having identified the area of concern, let's break it open and let's give some thought to this. So we're dealing with the string data type, and we know that the string is going to potentially contain either one numeric digit character or two numeric digit characters in the case of the number 10. But with the number 10 being slightly different, maybe it would be an idea to introduce it as one of the cases, and in the case that a 10 is chosen, we can just return the value 10 without having to do any real work on it. And then we know that the default case only has to identify whether the string is a single digit number in the range 2 to 9 or not. So if the default case identifies that the string is a single character in the range 2 to 9, then it can return that value as a number, which is what we've got already written into our code. And whilst this is potentially going to change, it gives us something that we can anchor our minds in. So we want to check that the string that has been passed in is a single digit string and that it's in the range 2 to 9. So we begin by checking its length. If the card value dot length is exactly equal to 1, then that suggests that we're halfway there. And then the second thing that we'll want to know is if the character within it is in the range 2 to 9 inclusive. So that would mean if the card length is equal to 1, and let's introduce a second criterion, if card dot char at position 0, which is the character itself, if that character is greater than or equal to the character 2, and if card.char at 0, which is our quick way of saying the first character, i.e. the only character, is less than or equal to 9, then that means that it is one of the valid characters. Now what we can then do is we can use this existing line of code to convert the number into integer format. Alternatively, we could now rethink this and say, well, having had to go in and perform the conversion to character twice, and then thirdly having had to convert it then to integer format, maybe there is a slightly more elegant way we could do it. But again, I'm taking advantage of short circuit evaluation here. So I'm saying that if the card's length is just one character long, then that's a good start. And then if that character falls within that character range in the Unicode character set, then we're good and we can proceed with this. So I'm just going to add a simple else case here just to draw this to a conclusion. I'm going to get it to output an error message to say invalid card, and I think that that's enough of a statement, and so I can return my dummy value -1 to say that it wasn't a suitable card. I'm going to right click and say format, let the IDE do any tidying up and adjustment to the way that I had laid everything out, and that completes the default case, therefore that completes the entire setup. And one quick test, just these values I've pasted in, and we should be able to see that, yep, it is able to pick out all of the invalid cards.